Let's talk about secret Git algorithm called similarity-index. I have prepared a few tasks that will help us understand this algorithm. The first task is focus on fixing a simple bug plus renaming the file. So yeah, let's deep dive into the code. So we have a test file which we will run it and we will verify what's going on here. So our test failed and the result is that we are waiting for John, but we actually got Peter. So why is that? After reading the code, you can see that we are using display person name, and this function is from a helper module. So we will open the helper module in the next column. So you can see that display person name returns the static value Peter. So we can fix it by using this parameter which is passed but which is not used here. So we will wait for a name value and we will return this name value. Let's rerun tests. Yes, perfect. Everything is working. Now we can move to the second item, second part of this task. So rename the helper.js file to something like person helper. Yes, we fix it and we can verify what's going on right now in the Git repository. So by running git status command, we will see that we have untracked files. So we will fix this by adding all of them to the staging area, and we will rerun the status command. Now we can see that we have a strange situation. We deleted a file and we added a new file. Plus we are modified the main file. Why is that? Why we are deleting and adding a new file? What's going on here? To investigate this process, this root cause, we can run git diff. By default, git diff is working only with living files, not from the staging area. So we can put option staged to work with the staged files. Oh, there is a lot of logs here. Yeah, maybe we can, instead of reading all of them, we can run this command with raw. So now we will working only on numbers. Here you can see that we have the same scenario, that we have a deleted file. This is the path, the full path, and adding a new file and modify this test file. What's going on here? Yeah, maybe we can read something in the git diff documentation. So we can run git manual git diff, and now we can find something which is called find renames. This is an option of git diff command. So in this description of this option, we can read about some similarity index. This is the special algorithm, special value which is calculated, and this value is based on some threshold. This threshold, default value of this threshold is 50. Okay, so what happens if we will change this threshold to, for example, to 1%? Oh wow! Now we can see that we have different operations. So instead of deleting and adding a new file, we have a renaming from helper.js to person helper.js. Wow, why is that? So this is everything related to the similarity index value. So when the calculated value is greater or equal a threshold, Git assumes that we are renaming the file. But in our case, the threshold is greater because the threshold is equal to 50 and our calculated value is 44. So it means when our value is lower than threshold, it means that Git assumes that we deleting and creating a new file. So that's why at the beginning we have 3 operations instead of 2 operations that we done exactly in editor. Okay, let's move on. How this algorithm works. So the formula is super easy. You can see that similarity index is calculated by number of bytes of unchanged lines divided by number of bytes in the result file, in the whole file, multiplied by 100 to get a percentage. Of course, range is from 1 to 100. The value at the end is rounded down to the nearest integer. We can verify in the next exercise. Next exercise is focused on how to calculate this similarity index manually. So there is another folder called calculate similarity index, and the task is to calculate similarity index for files which are inside. Okay. In this new directory folder, we have 2 files, super simple files. So the first one contains only foo, and the second one contains foo and bar strings. So yeah, we can open Node interactive mode and how to read bytes, because as I said, this index is based on bytes. So in the node we can use it by we can read bytes by file system function, which is called read file. Yeah, we can use synchronous function, and now we can put a path. That's it. Yes, so we got a buffer. So buffer is not readable, so we can switch it to JSON value. So in JSON value we have information that this is a type buffer, and we have a data array which contains bytes saved in this function. So in this file. So we have 4 bytes. Why we have 4? And in the file itself, we have only 3 chars. Yes, so we have 102 and 111 twice. What does it mean? These values came from ASCII table, and in ASCII table there is a definition of all chars that are available. So we can see that 10 in the ASCII value, so this is a decimal format, we have a line fit. So line fit, it means that this is a new line. This is a, sign that it is invisible in editor, but it is visible in the bytes. And 102 and 111, these are chars. So 102, this is F, and 111, this is O. So everything is understandable right now. So we can save this length of this array into one variable, and we can use the same by calculating values from the second file. 8. So one more time, going back to this formula, we can see that formula, this is the number of bytes of unchanged lines and divided by all bytes that are in the result file. So in our case, this will be F1 divided by F2 multiplied by 100. The similarity index value is equal to 50. How we can verify that our calculation is good? So we can copy the whole content of file 2 to file 1, and we can rename this file 1, for example, to file 3. And now we can run, and now we should add all files into staging area. Next, we can run git diff with staged, with raw to verify what happened here. And now you can see that there is a 50 value here in this operation. Excellent. If this value will be lower than 50, it will mean that we run two operations, but right now Git runs only one operation. You see that Git status see that operation of renamed was happen, not deleting plus adding a new file. Excellent. Let's move on. So I created, instead of manually a calculation, which is sometimes it's easier, sometimes not, I created a tool which is called git-similarity-index. This tool is available on my GitHub. I added some methods which are super useful, for example, to regular calculation, git-similarity-index, but I created a wrapper which is based on simple strings. You can see that we have different strings and we can calculate similarity index value for them. And of course, I created a wrapper on top of this, both functions, to just calculate similarity index based on two files, which is a super simple approach. So instead of reading bytes manually, we can just run this function, this command like that, and everything will be working. I put this tool into the npm registry, so it will be super easy to calculate this value dynamically. Okay, so we can calculate by this tool and to verify that everything is correct. So yeah, at the beginning, we can install this this command globally, like me right now, but we can, of course, run by npx to just run command without installation. So yeah, we need to reset the repository to compare correct files, not this new file. So it was a file 1 without bar, right? Everything is clear right now. Yes. Perfect. So now git similarity index, and we can verify what happened if we'll put both file names. You can see that the result is 50. So this is the same as our calculations returns. Perfect. Let's move on. The third task is how to reach 50% threshold. For example, why it is so important. For example, when we would like to track the file history, right? Because if we will create a new file, we'll lose the history of the previous file. I mean, when we rename the file, but the similarity index is lower than 50. So yeah, I created a third task, and this third task is based on two files. You can see on the left side there is a JavaScript version of display full name function, and on the right there is the same function, but it is a TypeScript version. So we can see that in the TypeScript version there is an additional interface which is not available, of course, in JavaScript. And now we can compare what is a similarity index both of these files, so main.js and main.ts. You see that there is a 38%. So it means that we have, if we will have this file at the beginning, I mean the JavaScript version file, and we would like to migrate this file to TypeScript, plus creating interface, which is a good pattern, we will lose the history of this file, of this new file. So how to resolve this issue? So we can, for example, add comments like this one. We can add it such comments to increase the number of similar or the same bytes. You can see that value was increased. Awesome. But yeah, how many times I need to do that? I don't know. Maybe that? No. Still, we are not reached the threshold. And now, yes, this is the more than 50. Excellent. But this is, manually work, so it's hard to scale it. So I prepared a script. This is the script which calculates exactly the number of bytes which is necessary to increase, to hit the threshold, and how this algorithm works. Oh, this is a super simple formula. Probably you remember the original formula, which is based on unchanged lines divided by results file, bytes of results file. And now we know the threshold, and we would like to calculate x. So after some modifications, the x value is equal number of bytes in the result file minus duplicated value of the bytes in unchanged lines. So this is the formula. Exactly this line is the line which calculates the missing value. Awesome. So I will remove all my changes which I've done here, and I will verify the similarity index. Awesome. And now I will run this script to calculate how many lines I need to add to reach the 50%. You see, this is the same comments, number of comments that I have had to add. So it was 7 yo comments. Awesome. But maybe instead of yo comment, maybe I can use lorem ipsum, for example. And how many lorem ipsums I needed to add? Yes, I needed to add only one lorem ipsum at the end of both files to increase the threshold, to increase the similarity value. We can verify how it looks like that. Perfect. By adding only one comment, one long comment, we increase the similarity index and we reach 50% of similarity index. Awesome. Thanks a lot. But I have a bonus for you where I can read about similarity index. Of course, as I show you, there is a documentation in Git diff commands. Of course, there is documentation online available on git-scm.com. Maybe you have a question about git move command, because everybody knows about that we have a command. And yeah, this command doesn't work like we can assume. So git move under the hood run 3 other commands. So this is the list of commands that git move run. So at the beginning, we just move the file in the file system. So this is a low level command. And after that, we are removing the old file from the Git repository, from the index of this repository. And next we are adding the new file. So this is a super simple list of commands that gitmove ran it. If you thought that gitmove eliminates this issue, it doesn't. Thanks a lot for this talk. Have a good day. Bye bye.